Okay, so today we're going to go through how to graph inequalities in two variables. So in lesson 5.5, we were graphing inequalities with just one variable. We are doing that on a number line. We have also in the past graphed equations with two variables, but those have been equations, not equalities. And we found out that the solution to an equation was all of the points on a line, all of those values that would make the equation true. So now we're going to move on to graph inequalities with two variables. So rather than it looking something like this, like y equals 1 plus 0.5x, we're going to graph something like this. Y is less than 1 plus 0.5x. So in order to graph, there's a few steps that we're going to take. The first being, we're going to consider what this would look like if we just switched out the inequality symbol with an equal sign. So basically just think about this as if it was an equation. So like y equals 1 plus 0.5x. And that line there is going to be what we call our boundary line. It's going to be our boundary line. And we'll draw that boundary line with either a dashed line or a solid line. A dashed line will be used for anything that has just greater than or less than. And a dashed line will look something like that. Whereas a solid line will look like this, and it will be used for greater than or equal to, or less than or equal to. And then for an inequality, a solution is not just going to be any point on the line, it's actually going to be what's called a half plane. So a plane is like, you can think about it like a piece of paper. It's that whole entire surface area. And when we're talking about a half plane, it's going to be just half of that. It's either going to be like above or below the line. And what we do, how we figure that out, is we select a point that's not on the boundary line, and we just plug it into our inequality to determine if it's true or false. So for this example, I used this inequality, y is less than 1 plus 0.5x. So again, I thought about it just like the equation that I was looking at up here. I thought about it like y equals 1 plus 0.5x, and I graphed that line. I used a dashed line here because it says less than. There's not that equals to sign as well. So I did the dash line for that. And then I selected 2 points. I selected a point that was above this line and a point that's below the line. And what I did with those points is I used the coordinates, I used those numbers, and I plugged them into the inequality. So for example, I used 0, 3, this point on the y-axis. The point 0, 3, where 0 is x, 3 is y. I plugged that into my inequality. So I got 3 less than 1 plus 0.5 times 0. When I simplify, I get 3 less than 1. But 3 is not less than 1, that's false. Okay, so I know that this up here is not going to be the solution. So I tried a different point down here, 0, negative 2. Again, 0 is my x, negative 2 is my y, and I plug that into this inequality, where I'd get negative 2 less than 1 plus 0.5 times 0, which simplifies down to negative 2 is less than 1, which is true, and therefore this whole half plane, this whole area underneath this dashed line, that's going to be my solution. Okay, so big concept is that the solution to an inequality is going to be not just a line, not just a point, but it's going to be a region, a whole area. We call it a half plane. Okay, let's keep going. We're going to look through an example. So what we're going to do is we're going to check to see whether each point listed here is a part of the solution to the inequality 2x minus 3y greater than 3. And then we're going to graph the inequality. So all we're going to do is we're going to take these points and we're going to plug them into the inequality up here. So in this first point, my x coordinate is 3, my y coordinate is -2. So I take those two numbers and I plug them in up here. So I get 2 times 3 minus 3 times -2, and I'm checking to see if it's greater than 3. So 2 times 3 is 6, minus 3 times -2 is -6. Is that greater than 3? Well, this turns into 6 plus 6. Subtracting a negative number means addition, so that's 12 greater than 3. Yes, that is true. Right? Now the next one, I'm going to plug in 3 for x and 1 for y. So I get 2 times 3 minus 3 times 1 greater than 3. I want you to pause the video and simplify on your own, and then come back with when you're done and check your answer. Yeah, so we get 6 minus 3 greater than 3. Well, 6 minus 3 is 3. Is 3 greater than 3? No, that's false. That's not true, because 3 is equal to 3. 3 is not greater than 3. So that one's false. Right, and again, I want you to do these last two on your own. Pause the video, work on it, and then come back when you're ready and I'll go through them. So you should have gotten false for the third one and true for the fourth point. For the third one, we just plugged in -1 for x and 2 for y, which simplified down to -8 greater than 3, which is again false. And then for the fourth one, we plugged in -2 for x, -3 for y, which ended up simplifying down to 5 greater than 3, which is true. So what we're going to do now is we're going to graph the inequality. So our first step is to graph the line as if it were just an equation. So I'm going to take that inequality and rewrite it down here. So I had 2x minus 3y greater than 3. So let's rewrite that as if it were an equation. So I'm just going to replace my inequality with an equal sign. So 2x minus 3y equal to 3. And think about what form this is written in. Think about it. I feel like Dora the Explorer when I do this. I ask you a question, and then I answer it myself. Yeah, it's in standard form. Standard form. So when we graph something from standard form, I think the most efficient way of doing that would be to find the x and y intercepts. There's a couple other ways we could do it. You could rearrange it so that it's in slope-intercept form, or you could create a table. But I like to find the intercepts and graph those. So let's do that. So first thing we're going to do is find our x-intercept. So finding the x-intercept, that's where the graph crosses the x-axis down here, right? Somewhere on here. So any point on this line We're not going up or down at all, so the y value of any point on this line is going to be 0. Therefore, to find the x-intercept, we need to plug in 0 for y. So let's go ahead and do that. So for 2x minus 3y equals 3, I plug in 0 for y, so I get 2x minus 3 times 0 equals 3. And that simplifies to 2x minus 0 equals 3, which simplifies to 2x equals 3, and therefore x equals 3 over 2. So that's my x-intercept. To find the y-intercept, so the y-intercept, remember, is where the graph crosses the y-axis. So any point on this line is going to have an x-coordinate of 0, since it's not going left or right at all. So what we do is we plug in 0 for x. So how about you pause the video, give that a try, and then come back when you're ready and we'll go through it. So you should have gotten -1 as your y-intercept. When we plug in 0 for x, that simplifies to 0 minus 3y equals 3. And then we divide both sides by -3, and y comes out to be -1. So now let's scale our coordinate plane and then plot those two intercepts. So I'm going to do like that. And so what we get is, I'm going to plot my two intercepts now. I'm going to like kind of count like that. 1, 2, 3. That's negatives, and then these are positives. Oops. And do every other. 1, 2, 3, 4. 1, 2, 3, 4, and then -1, 2, 3, 4. So my x-intercept is at 3 over 2, which is equal to 1 and 1/2. So I go right there, and that's going to be my x-intercept. And then my y-intercept is at -1, right there. And what I'm going to do is I'm going to use a straight edge of some kind, a sticky note pad, to draw out my line. But you know what I just did? So the second piece of graphing an inequality, so we just graphed this equation, right? But for an inequality, remember, we need to either use a dashed line or a solid line. A dashed line is for greater than or equal to. Solid line is for greater than, dashed line is for greater than or less than. Solid line is for greater than and equal to or less than or equal to. For this inequality, we have 2x minus 3y, 2x minus 3y greater than 3. Since it's greater than, I should have used a dashed line. So I'm just gonna kind of gently erase so I still know where I'm going, and then just redraw it with a dashed line. Okay, so now I have my boundary line. And what I need to do now is I need to take a look at these points that I tested out up here, and where those true points are, that's the area that I'm going to shade. That's the half plane that gives us the solution. So let's plot all 4 of those points. So first we have 3, -2. So that's 1, 2, 3, negative 2. So that'd be right there. That's point I, or point 1. 3, 1 is going to be right there. That looks like it's like almost on the line. Maybe it is on the line. But that came out as false. That's going to be 0.2. And then negative 1, 2. That's my third point. It's also going to be false up there. And then negative 2, negative 3. That looks like it's just under the line. That's going to be 0.4. And again, points 1 and 0.4 are true. So what I'm going to do is I'm going to shade in that half of the coordinate plane. And this is usually how I shade things in, is I just make lines like that rather than having to color the whole thing. Okay. Let's try another example. We're going to graph 2 more inequalities. So these inequalities, I can tell just by looking at them that they are either horizontal or vertical lines. So similar to equations, when we have an equation that looks like this, x equals some number, that's going to be a vertical line. And then y equals some number will be a horizontal line. So same thing with these inequalities, is we have a vertical line for the first one, and then a horizontal line for part B. So let's go ahead and graph these. Remember, first step is to just think about it like it's an equation. So like x equals negative 2. And create our little coordinate plane. And I need to go negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. It's kind of wonky, but that's okay. So x equals negative 2. Well, that would be, x equals negative 2 would be right there. So the line would go like this, vertically. But since I have that greater than symbol, I know that I need to do a dashed line. And now what I need to do is I need to check a point not on the line and see if it is correct. See if the inequality is true or not. So let's pick this point where we're at 2, 0. And I'll plug that in. So is 2 greater than negative 2? Is 2 greater than negative 2? Yeah, that's true. So that tells me that I need to shade this side of the inequality. And this half plane is going to be my solution. Now let's try this one. So we have 3y less than or equal to 1. So first thing we want to do is rewrite that with an equal sign instead of an inequality. And I'm going to solve for y so that I can have my equation in that intercept form. So if I solve for y, I need to get rid of this 3, which means I need to divide this side by 3 and the other side by 3. These threes cancel out, and I'm left with just y equals 1/3. Y equals 1/3, which again is going to be a horizontal line. So let us say that this is going to be 1, 2, 1, 2, -1, -2, -1, -2. That's 1. Then y equals 1/3 would be right there. Again, I'll create a horizontal line. And since now I have less than or equal to, I can do a solid line. Solid line. And then my last step is to test a number not on the line, so either above or below, and test to see if it works in the inequality. If it's true, that's the area I shade. If it's false, then I shade the opposite area. So let's try. Let us try. Let's try this. Let's try 0, 1. So if I plug that in up here, I would get 3 times 1 is less than or equal to 1. 3 is less than or equal to 1. Well, that's false. So I know that this area up here isn't going to be the solution. It has to be this area down here. Okay. Now let's do a couple more. These are part of the practice problems I have assigned for you. So number 6 says to sketch each inequality. We'll go ahead and we'll do these ones together, these 3 together. So the first one, again, let's write down our steps. So first thing we need to do is replace the inequality with an equal sign. Then graph. This is the boundary. Something to remember for less than or greater than, we use a dashed line. For less than or equal to, greater than or equal to, we use a solid line. Then we test our points. Test points. And then we shade the half plane. Okay. So these are our steps. Let's not forget them. And let's get started working on this one. So first thing I'm going to do is replace the inequality with an equal sign. That would give me y equals -3 plus x. And I'm going to graph that. This is an intercept form. So I know that -3 is my y-intercept, and 1 is going to be my slope. So I'll scale my graph. 3, 4, 5. So this will be -3. Let's do 1, 2, 3, 4, 5, 8. And 1, 2, 3, 4, 5, 6. -1, 2, 3, 4, 5, 6. So again, this is my y-intercept, and then my slope is 1. So I go up 1, over 1, up 1, over 1, up 1, over 1. And that's going to be my line. I check to see, is my inequality less than or greater than, or less than or equal to, greater than or equal to? It is less than or equal to, therefore I use a solid line. Solid line. So that will be my boundary. And now I need to test a couple points. So I need to test a point on this side of the line and on this side of the line. So let's test this one right here. That's 4, 0. And then let's also test 0, 0. So 0, 0, and 4, 0. So 0, 0, and I'm using the inequality, this y less than or equal to negative 3 plus x. So if I plug in 0, 0 into here, I would get 0 less than or equal to negative 3 plus 0. It means 0 less than or equal to negative 3. That is false. Let's try 4, 0. So I'd get 0 less than or equal to negative 3 plus 4. 0 is less than or equal to 1. That's true. So I want to shade the side that has the 4, 0 on it. So that's over here. So I can go ahead and shade that piece in. Right? Now let's look at the next one. We have 2x minus y greater than or equal to 4. First thing we want to do is we want to replace the inequality with an equal sign. Graph, and that's the boundary line. So let's replace the inequality with an equal sign. That would give us 2x minus y equals 4. We can see that that is in standard form. That's in standard form. So that means we are going to find the x-intercept and the y-intercept. I want you guys to pause the video and give that a try, and then come back and check your answer. So you should have found the x-intercept to be 2 and the y-intercept to be negative 4. So let's go ahead and graph those 2 points. My x-intercept is at 2, which is over here. My y-intercept is at negative 4, which would be 1, 2, 3, 4 would be right there. And now I need to graph the line. So I just need to connect those 2 points and allow the line to extend out in either direction. But before I do that, I need to determine, am I going to draw a dashed line or a solid line? Well, my inequality says that this piece is greater than or equal to 4. So I do a solid line. Solid line. Let's connect those points. And so this is my boundary line. This is my boundary line. So now I need to choose, let's choose 2 points again, plug them into the inequality, check to see if they're true so we can decide which half plane we're going to shade. So again, we need to choose something on this side of the line and on this side of the line. So let's choose this, and let's choose this. So over here we have 3, 0, and over here we have 0, 1. So 3, 0, and do it over here, and 0, 1. And again, I'm plugging it into this inequality, 2x minus y greater than or equal to 4. So I plug in 3 for x, 0 for y, and I get 2 times 3 minus 0 greater than or equal to 4. 2 times 3 is 6, minus 0 greater than or equal to 4. Yes, that's true. 6 is greater than 4. But let's just try 0, 1 just to be sure. So I plug in 0 for x, 1 for y, and I get 2 times 0 minus 1 greater than or equal to 4. 0 minus 1 is greater than or equal to 4. Yes, that's false. What am I talking about? Negative 1 is not greater than or equal to 4. So over here is false. On this side, it's true. So this is going to be my half plane solution, is this piece down here. Right? We've got one more to do. So first step, again, is to replace the inequality with an equal sign, and then we're going to graph that line. So I want you guys to give this a try on your own. Pause the video, and then come back when you're ready, and we'll go through it. All right, so this should have been the line that you came up with, determined by the x-intercept being 4, the y-intercept being -3. Just connecting those 2 points, I made it a solid line because my inequality has greater than or equal to. So now what I'm going to do is I'm going to test 2 points. So I'll test a point over on this side of the line. So let's test 0, 0. And let's test a point down here. Let's test 0, -1, 2, 3, 4. 0, -4. And I'm plugging those into this inequality. Equal to 12. So if I plugged in 0 and 0, I would get 3 times 0 minus 4 times 0 greater than or equal to 12. That's 0 minus 0 greater than or equal to 12. That's false because 0 is not greater than or equal to 12. Let's try this one. So we plug in 0 for x, -4 for y. So I get 3 times 0 minus 4 times -4 greater than or equal to 12. 3 times 0 is 0. -4 times -4 is 16, which is greater than or equal to 12. That is true. So the half plane that includes this point is going to be my solution. Right? We're going to work through number 7 in your practice problems as well. So I'm going to do 3 of the parts, and then I think there's 3 more that I want you to do on your own. What we're doing here is we're going to just write the inequality represented by each graph. So still the same kind of steps apply, where we need to first determine the boundary line, and then we need to test a couple points to see how we need to set it up to have the equals or the inequality which way. So we can see this first line is a solid line, so we know it's definitely going to be less than or equal to or greater than or equal to. But let's come up with the line. So I have, let's see, I have my y-intercept right here, right? Y-intercept. And I have another point, so I could very easily find my slope. So let's write this in slope-intercept form. Y equals mx plus b. My slope, again, is going to be 1. And then, or my y-intercept will be 1. And then my slope is going to be that change in y divided by the change in x. This looks like it's at 0.5. Okay, so my change in y would be 1. I go down from 1 to 0, so my change in y is 1. And then my change in x is 0.5. My slope, which in this case is going to be m, is equal to 1 divided by 0.5. 1 divided by 0.5. I could plug that right into my calculator. 1 divided by 0.5, and that gives me 2. And I can tell that it is a negative slope because from left to right the graph is falling. So my slope is going to be not just +2 but -2. So -2, and that's what I'm going to plug in for m. And then my y-intercept is b, so that's what I plug in here. So my equation for that boundary line would be y equals -2x plus 1. But now I need to change this equal sign into an inequality. So what I'm going to do is just test it out. I'm just going to test it out and see which one will work. I'm going to guess. I don't really know. I'm just going to guess. I'm just going to pick one. I know it has to be, you know, less than or equal to or greater than or equal to, since this is a solid line. So let's try less than or equal to. Let's try y less than or equal to negative 2x plus 1. And so if that's the case, then a point over on this side of the line, if I plug in the coordinates from any point on this side of the line, that should make the inequality true. So let's take that 0, 0 point, 0, 0. So let's plug that in. So 0 for x, 0 for y would give me 0 is less than or equal to negative 2 times 0 plus 1. So that means 0 is less than or equal to 1, which is true. Therefore, this is my inequality. Y is less than or equal to negative 2x plus 1. Okay, let's give this one a try. I want you guys to pause the video and try and figure out the boundary line equation. And then come back when you're ready and we'll go through it. All right, so you should have found your boundary line to be y equals negative 1/2 x plus 1. And maybe you came up with something in a different form. Maybe you used a different method. I'm using the slope-intercept form because my y-intercept and the slope is pretty clearly defined. So again, my y-intercept is where my graph crosses the y-axis, which is at 1. And then my slope is this change in y divided by the change in x. My change in y was 1. My change in x was 2. So that gave me 1/2. And then just by looking at the graph, I can tell that the slope is negative because the graph falls from left to right. So my slope will be negative 1/2. And my y-intercept is 1. So this is my boundary line equation. Now let's figure out the inequality. So again, it's a solid line, so I know it's either going to be less than or equal to or greater than or equal to. And it's really just a guess and check at this point. I'm going to go ahead and try this one out. Y is less than or equal to negative 1/2 x plus 1. And I'm going to choose a point over here in the shaded half plane and plug that point into the inequality to see if it's true or false. So I'm going to pick this point right here that's 0, 2, and I'm going to plug that in. I plug in 0 for x, and I plug in 2 for y, which would give me 2 is less than or equal to negative 1/2 times 0 plus 1, or 2 less than or equal to negative 1/2 times 0 is just 0 plus 1. But 2 is not less than or equal to 1. That's false. So let's try and flip the inequality and see if it would work that way instead, because we need this point to be true. So now again, let's flip the inequality. So that would give us, let me do it on here. That would give us y is greater than or equal to negative 1/2 x plus 1. And I'm again going to plug in this point 0, 2. 0 gets plugged in for x, 2 gets plugged in for y. So 2 is greater than or equal to negative 1/2 times 0 plus 1. Or 2 is greater than or equal to 0 plus 1. 2 greater than or equal to 1. Yes, that is true. So this is going to be my inequality. Y is greater than or equal to negative 1/2 x plus 1. All right, let me get this out of the way. We're going to work on our last one. This is part E, number 7 of our practice problems. And this is an example of a horizontal line. horizontal line, you might remember, is going to look something like this. Y equals some number. And that number will be wherever it's crossing the y-axis, whatever number it's like staying consistently at, which in this case will be 2. So y equals 2. That's my equation for the boundary line. I know that it's going to be less than or equal to or greater than or equal to because it's a solid line. But we need to just do some guessing and checking to figure out which one it is. So let's try the first one. Y is less than or equal to 2. So, and then what I'm going to do is I'm going to just pick a point in the shaded half plane. So let's pick this point right here. That's 0, 1, where y is equal to 1. So I plug in 1 for y, which gives me 1 is less than or equal to 2. That is true. And therefore, this would be my inequality, right? So you guys have a few more practice problems to work through. They're all posted in Google Classroom. There's also a Google form for you to complete. If you get stuck or if you have any questions, please let me know. I'm happy to help. All right, I hope this video has been helpful. Thanks a lot for watching. I appreciate it. Hope you're all having a great day.